I swear, if UPSC going to continue this trend, all the students are going to crack this exam. Literally, they are giving back to back very easy questions. See, the question number 32, you have to suppose this for like two of the questions. So first one is your question number 32. In this question, x1, x2, xn be a random sample from your normal distributions. So generally, I'm going to write xi follows your normal distribution with mean mu and variance sigma square. The value of s square is given to you and you have to find the moment generating function of s square. So right now for the session 2025 to 2026 in my batch 1, I am teaching chapter number 7 which is related to MGF. So for all those students, this question is very easy because you have learned MGF now in this month, which is the month of your June. Okay, so you have to do this question, okay, by your own. If you are watching this video, do this question and write down the option number directly in the chat box without looking at the solution. Okay, so now those who have no idea about it, just look at here on the screen. The value of s square is given to you, which is your n minus 1 summation I is going from 1 to n xi minus x bar whole square. Okay, so you can see we have n minus 1 here, s square, and in the right hand side we have summation I going from 1 to n xi minus x bar whole square, dividing it by sigma square, dividing it by sigma square. Why we are dividing it? Because we have learned in the chapter number 9 about the relation of normal distribution with the standard normal distribution with the chi-square distribution. Okay, so now that's why we have divided it with sigma square. Okay, so okay, I'm also going to tell you, I'm not going to skip that. One thing we have learned that when x follows normal distribution with mean mu variance sigma square, then if we are going to change its origin and scale, you can say with changing the origin with mu, changing the scale with sigma, that is x minus mu upon sigma, it is called your standard normal variate. A standard normal variate always follows normal distribution with mean 0 and variance 1. And if we are going to square the standard normal variate, it follows your chi-square distribution with 1 degrees of freedom. If we are going to take summation over I here, then xi minus mu upon sigma whole square, it will follow your chi-square distribution with n degrees of freedom. If at the place of mu, we are going to put x bar, it will follow instead of n, it will follow chi-square distribution with n minus 1 degrees of freedom. So this is the concept that I am going to use. That is why I have divided it with sigma square. So that directly what I can write here, summation I is going from 1 to n xi minus x bar upon sigma whole square. So this is the same thing that is written here, you can see. Okay, everyone. So now I'm going to rub it so that I can have a space to solve rest of the part of this question. Okay, now you can see I have this and this is following your chi-square distribution with n minus 1 degrees of freedom. Okay, now we have this value in the left hand side, you can see, and we have this value in the right hand side which follows. That means this is following your chi-square distribution. Okay, and we have to find the moment generating function of this s square. So what we are going to do now, we are just, okay, one more thing you have to remember in this question. If you want to do this question in short time period, like 15 seconds, 20 seconds or 30 seconds, what you have to do? You have to remember, you have to learn the MGF of chi-square distribution. So I am directly writing here the MGF of chi-square distribution. It is your 1 minus 2t whole to the power minus n by 2, right? So also everyone, if you have no idea how to drive it, or other concepts of chapter number 9 you want to learn deeply for your ISS or for your graduation, for the post graduation, you can join my live classes. The information is given in the bio. Okay, so we want to find out the MGF and this is what we have to remember now, that we have to use it. Okay, now everyone, you can see what we have here. We have this thing here, we have to find the moment generating function. So I'm going to write down the general formula of moment generating function for a random variable x. So the general formula is mxt expectation e to the power tx. Okay, and we already know how to expend or how to find expectation of any function of x. Now, we at the place of variable only, we have this whole value. So, we are going to put m at the place of x. We are going to use this whole. Okay. So, what we can write here? We can write m n minus 1 sigma square of s of t. And what we can write here? M s, we are keeping s square. Okay. Not doing this. Let me do it again. At the place of this, I'm going to use the formula expectation e to the power t, and at the place of x, what I'm going to write? N minus 1 upon sigma square s square, right? And now rearranging it. If I'm going to rearrange it, what I will write? I will write expectation of, now taking e to the power s square separate and separating t n minus 1 upon sigma square, because we know t n minus 1 is a constant, t is a real number, n minus 1 is a constant, sigma square is also constant. Okay, so from here what we are going to do now, we are just going to rewrite it again. What we can write, m square of t, but at the place of t now what we have, t times n minus 1 upon sigma square. So I used a property here of your moment generating function. Okay, we can rewrite it, and those who have already learned chapter number 7 from me, you all are getting this. Okay, well, I have easily explained it every step here. So if you are getting any confusion or problem, please do let me know in the comment box. Okay, so now everyone, I am going to rub it so that I can solve the rest of the part. Okay, so now you can see everyone, now we have to write the moment generating function of this s square, and you can see this like similarly you can see this is what, let me highlight it again, this is the function which followed chi-square distribution with n minus 1 degrees of freedom. This is what we have already seen here in the portion that I rubbed. Okay, now after that we have to write down the moment generating function of this part, which is chi-square distribution with n minus 1 degrees of freedom. But this is the moment generating function of chi-square distribution with n degrees of freedom. Okay, now I am going to write it here for n minus 1 degrees of freedom. So for n minus 1 degrees of freedom, the moment generating function is 1 minus 2 t whole to the power, for n at the place of n we have to replace n minus 1, right, and by 2. But here in this question you can see we have derived this much, and here in this part at the place of t what we have to write, because we have to find the moment generating function of s square, but here we have this function which follows chi-square distribution. So taking the help of mgf of chi-square distribution, we got the mgf of s square, but at the place of t what we have to put, we have to put this value in this part. Okay everyone, so you can see what we can write, 1 minus 2. Okay, let me write it properly again. We can write 1 minus 2, but at the place of t we have to write this, t times n minus 1 whole upon sigma square, and bracket close, whole to the power minus n minus 1 by 2. Okay, so now you just can check out the option number A. It is given in option number A. Isn't it very easy? Okay, those who already know about chapter number 7, chapter number 9, and chapter number 6. Why I am calling it chapter number 6? Because it is also using the concept of expectation, and like, you know, every chapter is interrelated. So you should have the information of every chapter. So only then the questions will be easy for you. So I hope you all like this solution. Do let me know everyone in the comment box. If you have any problem, you can also join my live classes. Also, don't forget to follow me on Instagram. So thank you everyone for joining it. Have a nice day.